Alright, so in this lesson we will analyze and represent geometric sequences. Before we begin, I just want to let you know this is my sixth and final video that I'm doing this Sunday night, so hopefully, I'm going to do my best to make sure I'm on it, not rushing through anything. So, let's talk about geometric sequences. Now, last lesson we did arithmetic sequences. Arithmetic sequences are when you keep adding or subtracting over and over and over again. This time we're doing geometric ones. Instead, we will be multiplying by the same number over and over and over again. I do want to stress these ellipses. This means that this sequence of numbers keeps going like forever, pretty much. I mean, I guess you could stop it somewhere, but like these ellipses just means it keeps going, right? Now, if you can multiply by a positive number, you can also multiply by a negative number. Like this is -1 and 5/10. You can just keep multiplying by this, but a positive times a negative will give you a negative, and a negative times a negative will give you a positive, and a positive times a negative will give you a negative. This is why you have positive, negative, positive, negative, positive, negative over and over and over again, because if you multiply by negative, it's going to change your value. Now, in something like this, you're going to automatically want to divide by 4, because you can see divide by 4. But remember, if you can divide, you can also represent it as multiplication. Times 1/4 times 1/4, which means times 0.25 times 0.25, just whatever you want. All right, now a formula is going to be different because we're not adding or subtracting by the same number. Once again, the n here is the term number. Okay? Remember that like this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. So, and a sub 1 is the first term. So 1, 4, 80, 100, those are all the first terms. R is something called the common ratio. This is the number we keep multiplying by. And this is, remember that this right here is not multiplication. It's not r times n minus 1. Remember, this is this is exponent. We'll say exponent, for lack of a better word of explaining it, because, I mean, there's more than one thing up there, but we'll just say exponent. You're not going to be multiplying. So, right here, a sub n equals 3 times 2 to the power of n minus 1. Or to n minus 1 power. So the first term is going to be 3. Remember, this is a sub 1, and this is the common ratio. The first term is 3. First term is 3. That's our first term. The sequence multiplies. So we start at 3. We won't keep multiplying by 2. That means the common ratio is positive 2. We keep multiplying by it. The third term, so we have the first term, second term, third term, fourth term, so on and so forth. So we can see that we're multiplying by 2. We get 6. Multiply by 2, we get 12. So our third term is 12. So our first term was 3. We multiplied by 2, so our second term was 6. We multiplied by 2, so our third term was 12. This one asks for the fifth term, so let's get there. 12 times 2 is 24. Times 2 is 48. Sweet. So now let's go ahead and prove that this goes with these. This equation goes with these terms, right? If you want, you can put some comments here. I didn't want to put them because it looks a little messy in the process. So a sub n equals 3 times 2 to the power of n minus 1. So let's do the fifth term. 3 times 2 to the power of 5 minus 1. So 3 times 2 to the power of 4. So 2 times 2 times 2 times 2 to the 4th power is 4, 8, 16. So 3 times 16. And the fifth term, 3 times 16, should be 48. 1, 2, 3, 4, 5. It is in fact 48. All right. Let's try this one. So the first term in this one is 8. And then we keep the sequence multiplies by negative half. Therefore, the common ratio is negative half. So on to the third term. Let's just start off. So we have 8 is our first term. Multiply by negative half. Positive times a negative is a negative. 8 times half is 4. That's our second term. Multiply by negative half again. Negative times a negative is a positive. 4 times half is 2. That's our third term. Alright, so our third term is 2. Remember, these aren't fractions. Those aren't fractions. So our first term was 8. Our second term was negative 4. Our third term was 2. We want to get to our fifth. So let's multiply by negative half. Positive times a negative is a negative. 2 times half is 1. That's our fourth term. Let's multiply by negative half. A negative times a negative is a negative. 1 times half, 1 times anything is the same thing, so half. You could also put 5/10, like 0.5 if you prefer. So negative 1/2. Let's prove it again. So a sub n equals 8 times negative half n to the minus 1 power. So let's do this third term because 2 is a nice number, nice easy number. So 8 times negative half times to the power of the third term minus 1. So 8 times negative half twice to the second power. So negative half, you can just, in decimal form, it doesn't matter. You can do it like, I'm just going to show you, because most of you will probably use a calculator like on your computer or something. Negative times negative is positive, so that's 1/4. At this point, you'll either have this, or if you use like a calculator, you would have this. But either way, you'll get 2. So a sub 3 of the third term is 2, or you would have gotten the third term is 2. And the third term was 2. Good. So we're almost done. So I know this is arithmetic. Let's ignore that. This is geometric. Let's ignore this. Geometric. Just make sure you're doing geometric here. So in this one, we can see that it's just times 2, times 2, times 2, times 2. Now, let's say we didn't know that. If we don't know what we'll multiply by, then we divide in the opposite direction. So if we're going this way times 2, we would go this way. 6 divided by 3 is 2. Or we could do 48 divided by 24 is 2. So it's times 2. let's write our formula. Remember, our general formula is a sub n is the first term times the ratio, common ratio, to the n minus 1 power. So a sub n, so that stays the same. Our first term was 3. And we multiplied by 2, or I like to put it in parentheses, n minus 1 power. If you don't like that, you can also write it as that. And then you know how to prove it. Now, let's look at this one. So this one, you're probably not going to know what you're going to multiply by. So if we don't know what we're going to multiply by, then we divide going backwards. Negative 27 divided by negative 51. So if I'm going to just take a random, I'll take my phone calculator because I know that's what a lot of you are probably going to be doing. So I'm going to type in negative 27 divided by negative 51. And I get this weird number. It's like keeps going on like forever, it looks like. So maybe I did something wrong here. I'm going to try this again. 27 over 51 equals, yeah, that shouldn't be a 51. So this is times 3 times 3, 27 times 3 is, this should be an 81. So let's change that to an 81. Because I don't want to do the whole video over again. 81. So we do that, and you end up with a negative over negative is a positive, 0.33 repeating, which is 1/3. So 0. You can either put like that, or you can do this. You can test it out too. If you prefer, you can do negative 3 over negative 9. Negative over negative is positive 3/9, which reduces to 1/3. Point is, it's 1/3. So we start off with negative 81, because remember, we changed it. That's what it was supposed to be. I just made a mistake. Times, common difference is 1. I'm going to leave it in fraction form. 1/3 n minus 1 times. And y'all can show the proof. I'm going to do one more. So I'm going to do this 128. So it's just the fourth term. So 1, 2, 3, 4. And then it gives you the fifth term, 5. So this is the fourth, is 128. The fifth term is 512. Remember, if I don't know what I'm multiplying by, then I have to divide. So 512 divided by 128 equals 4. So that's times 4. But this is times 4 going this way. So to go backwards, I would have to divide by 4. So 128 divided by 4 equals 32. Divided by 4 equals 8. Divided by 4 equals 2. I can test this. Times 4, yeah. Times 4, yeah. Times 4, yeah. So, okay. So I'm good. So I start off with 2 multiply by 4 n minus, to the power of n minus 1. And of course, you know how to show proof. You pick any of these and you plug it in, you're fine. That's it. Thank you.